In this video, we're going to have a look at another leaning rod question. This one is rather interesting because here we have a force acting at the point B, and we're not given any information, additional information about the angle at which the force is acting relative to the rod. Or the magnitude of the force. So this would cause us to depart a little bit from the generalized routine that we have been practicing, which is force diagram, resolve vertically, resolve horizontally, and then take moments at about the point A. So we'll still do our force diagram, but we're not going to take moments at A because we have less information at B. It would be judicious of us to take moments at B rather than at A. So let's go through the standard approach. So we are going to have reaction at A, which I will ordinarily label RA. We have a uniform rod of mass 20 kilogram, so it means that weight is acting down the middle. And we have 20G right here, which we would resolve this way, and we would resolve this way, recognizing that this angle right here is going to be the same as alpha. In the question, they tell us that tan alpha is 3/4. We can do a quick diagram here. So alpha tan is opposite over adjacent, and by Pythagoras' theorem, that will be 5. We can identify what cos alpha is, which is going to be 4/5, and that sine alpha is going to be 3/5. Now, of course, you could have done tan inverse of 3/4, found alpha, and then worked out sine of that answer and then cos of that answer. But I prefer that approach. Okay, so what we'll want to do here, we know that the rod is held in limiting equilibrium at an angle. So it's on rough horizontal ground. That tells us here that friction is going to be maximum friction, and the coefficient of friction is 0.5. So that would be 0.5 times RA. So because I'm going to be taking moments about B, I don't need to resolve the force here. But what I will need is to resolve the force at A, which I don't normally do, but in this case we'll be doing. So we're going to resolve this force RA this particular way. That's 90 degrees. This will be 90 minus alpha. Consequently, this will be alpha. And then this part will be cos RA cos alpha. So that will be 4/5 RA. And this will be 3/5 RA sine alpha. And do convince yourself that that is actually the case. So for RA, for the frictional force, we're going to resolve it this way and this way. All right. So this is alpha. This will be 90 minus alpha, and then that's 90 degrees right here, and then alpha right here. So this means that this bit right here will be 0.5 RA times cos alpha. So that bit will be 4/5 times a half RA. And then this bit right here will be 0.5 RA times sine alpha. So that bit right here will be 3/5 times a half RA. Okay, so I think we have all the information that we need now to work out find the magnitude of the normal reaction of the ground. So our goal is to work out what RA is. So here now, we have done our force diagram. We're going to skip from step 1, from the usual routine, to step 4, which is find moments about the point. So we find moments about B rather than A because there's less information at B than A. So moments about B. So we're going to do distance times perpendicular component of force plus distance times perpendicular component of force equal distance times perpendicular component of force. So the anti-clockwise and the clockwise turning effects will be perfectly balanced because the rod is in limiting equilibrium, in equilibrium. All right, so applying this part here, the distance of the length of the rod is 4. So it'll be 2 times this part here will be 20G cos alpha. So 20G cos alpha is 4/5 plus 4 times 3/5 times half RA. And that will perfectly balance the 4 times 4/5 RA. So here now what we want to do is to group the like terms and then just rearrange for RA. So we're going to have 2 times 20G, 2 times 20 times 9.8 times 4/5. So that will give us 313.6 plus 4 times 3/5 and then times that by 0.5. So plus 1.2 RA is equal to 4 times 4/5 RA, 3.2 RA. So when we group the like terms, 313.6 is equal to 2 RA. Therefore, RA is 313.6 divided by 2. So that is 156.8, or RA would be approximately equal to 160 to 2 significant figures. All right, so it's really useful to do like loads of these examples, and that's why in the channel we have quite a number of these examples so that you can see how clever the examiner can be when it comes to changing up the details in the questions, and you want to be really prepared to manage any slight change in the context of the problem. All right, so I encourage you to subscribe, to share, and to like, and catch you in the next video.